This conference will now be recorded.
Hello, I'm very glad to welcome you today on our DigiFoF webinar, Applied Modeling Languages in Development of Industrial Applications. My name is Zbigniew Misiak and I'll be your host. Just to make sure that you remember everything about the technical aspects, if you have any questions, feel free to expand the GoToMeeting GoToWebinar panel. There you can ask questions, and at the very end, we'll have Q&A part where our presenters will be answering your questions. And now, I think without further ado, I would like to introduce our presenters. So today our speakers will be Victor, Maria, and Octavian. And this is the agenda of the webinar. So you can see there are several points, and we will begin with Victor. So Victor, floor is yours.
Okay, thank you. I will share my screen. Yes. And it will be. Okay, so thank you for the presentation. In the first place, hello to everyone. This is the agenda. In the first place, it will be an introduction regarding ADO-XX and modeling languages. After that, we will talk a little bit about smart city and smart city problems. After that, my colleague Maria will present her part where he developed something to resolve the parking problem from smart city. And after that, Octavian, it will show his part. In the first place, I want to talk a little bit about the ADO-XX. In the first place, we need to install the both of the system, the platform from ADO-XX.com. The first platform, the first program is ADO-XX development, and the second one is ADO-XX modeling toolkit. We need to create users because in the first place we have one user that is default, but to use simultaneously, the first way we need to have another user and assign it to the right development. Okay, after this, maybe it's okay to discuss a little bit about the first some things, how we define a model type, how we define a modeling relation class, and after that the representation. The graphical representation, and to assign to a model type. We can talk a little more about different scenarios that can be implemented in modeling languages regarding the smart city or anything else that maybe we can use to implement or to simulate to this. In the first step for installation, we need to request a key from BOK. After this key it will be received, we can download and install and create our database. We will have two different programs: development toolkit and modeling toolkit. How I said earlier, the default username and the password is admin and password. This I recommend to use it only until we create our own users. After we will create the users and can use the actual platform with our credentials, then we can try to implement the first model, hello world. In this step, to achieve this, we need to follow some steps. Define model types is the first one. After that, we need to define the model and modeling and relation classes, because this is used to make a relation between those two model types. we need to apply a graphical representation on each model type to can see it in toolkit. And after that, to assign the class to a model type, because a model type is only a model which help us to create more classes. Okay, in the first step, we will use development toolkit to create the model type, and after that, you'll use the other application to define the class. After this short presentation about the ADOX6 and how we should start, I think it's better to try to talk a little bit about smart city and what we want to develop here in Sibiu and what we discussed over the laboratory and everything. The problems are of the smart city. What is smart city and what we use to create it. A smart city, it's a city where all the buildings, the cars and everything communicate between them. So this is the goal to achieve when we talk about smart cities. So in a smart city, we have to achieve a good smart city, we need to resolve some problems, which are the first big problem is the traffic, because we all of us spend a lot of times in traffic jams, and how we can resolve this with IoT and with modeling languages. We can create some flows where to see to see how we can make the all participants of the traffic to communicate between them and make easier to not to resolve the traffic jams. After with these traffic jams, we not only spend our time, also we spend our money, because a lot of fuel it's wasted. With Internet of Things, we can merge all of our buildings and cars and everything from the traffics in one ecosystem and try to solve it. Another big problem in a smart city, it's smart parking. It's the parking. We try to resolve it with smart parking, because for all of us it's so important to, if we need to go somewhere, to have a parking spot and not to search it, I don't know, half an hour to until we find an empty spot. Regarding this problem, I will let my colleague Maria to talk about this and to show her point and how he thinks that we can solve it. Thank you very much.
Thank you very much, Victor. Now I'll pass the presenter right to Maria.
Thank you.
Looking great. So you can continue from your part.
Yes, just a moment. I have some problems. So, hello everyone. My name is Maria, and I am a student of Lucian Blaga University in Sibiu. Now I am a software developer engineer in an automotive company. The first time when I heard about a modeling concept was last year when I participated at the Nemo Summer School in Wien. Then I decided to prepare my project for a bachelor degree together with Professor Adrian Florea, and in the next few minutes I will present you my project, which refers to the modeling concept, modeling languages using a mobile robot. Nowadays, most of us lost a lot of time in traffic because there are more and more cars and cities are becoming more crowded. So started from the idea of a smart city, my project has the idea of a smart parking and how to create a harder software application for solving the problems like streamlining traffic, reducing search time for a parking space, reducing full cost, and of course reducing the pollution. The goals for me was to create a scenario that can be simulated using the modeling languages and also the tools provided by OmiLab and the hardware, of course. In my project, the hardware is a mobile robot. For my project, I followed the 3 levels approach to create 2 scenarios. Because I was and I'm still a beginner in this area, I decided to take the things step by step. So in the first scenario, I modeled the mobile robot to park at a place chosen by me or by who simulates the application. And in the second scenario, I used more external sensors from the mobile robot to make it to park itself in the first free place. So like I said, the first level from the approach used is design thinking. In this step, I created 3 scenes, which are the same for the both scenarios. In the first scene, we have a girl who is from a city and wants to go to another one for shopping, for example. So she will take her car and will leave his house. In the second scene, the girl arrived in that city and need to be careful at the pedestrians and traffic signs. And in the end, she arrived in the front of the parking. And in the third scene, for the first scenario, the girl will choose a free place for the from the parking and the mobile robot will go there. And for the second scenario, the mobile robot will decide itself in which place to park. For all these 3 scenes, in the left side, you saw the real representation, the real elements, and in the right side, the virtual representation created using the Synth model tool. Like I presented before, these are all 3 scenes and the order between them. For the second level from the used approach, for each scene, I created a BPMN model to illustrate in a better way the order of the actions. So for the first scene, the BPMN model is like it follows. The girl will get into the car, we'll check if she has the keys. If not, we'll go to take her keys, and then she will start the car. For the second scene, the girl will drive the car, will respect the signs and take care of the other elements in traffic, and finally will take a ticket to entry in the parking. And for the third scene, we'll get into the parking and drive between places, choose a free place and stop the car. All these models could be done in much more details, but the most important part from my point of view was the last level from creation. Before moving on, all these 3 BPMN models, all 3 scenes was connected using a storyboard. Now the third level, cyber physical system. In the left image, you can see my parking real representation and the mobile robot. I chose to have 6 slots in the parking, and in the right image with red arrows, I represent the actions made by Mbot mobile robot for a simulation of parking in the first place. It will start with the first straight arrow from the left side, then we'll make a left rotation, again straight, again a left rotation, and then straight. And now for the first place from the parking, the left rotation and straight until the mobile robot will read the white surface with the line following sensors. For the first scenario, the model is this one. Like I said before, in this case, the mobile robot will go to a fixed location chosen by the person which will simulate the model. I used flowcharts, diagrams, and other scripts code. For exemplification, I will present now a short video. In the left side, you can see a list of and from this one I chose the second place from the parking. the mobile robot will action in the following way. So it will start from the start place. It will make a left rotation, will go straight, and now again a left rotation, again straight, and it will stop in front of the second place, will make a left rotation, and it will go straight until the line following sensors will read the white surface. The second scenario, in this one, the mobile robot will choose itself a free place, and it will park there. The difference between the scenarios is that in this one I used one more sensor from the mobile robot, the distance sensor, the proximity sensor, and the video for the second scenario is this one. In this one, the mobile robot will park in place 3. In the first part, it will make the same actions like in the previous scenario, but now it will check firstly the first place. I use the box to that indicates that the place is not free, so the mobile robot will saw the box, and it will consider that that place is not free. The same for the second place, and for the third place, I didn't use the box, and the mobile robot saw that that place is free, and it will park there. Because I was curious how PetriNet works, I realized the first scenario using also this modeling language, and like further developments, I want to implement a scenario and using the camera from a mobile robot to make it to recognize the pedestrians and traffic signs, and maybe to add more sensors in the sides of the mobile robot to improve the current scenarios. Thank you very much for your attention, and now I will let my colleague Octavian.
Thank you very much. Now I'm passing presenter right to Octavian. So if you could prepare your slides, it would be perfect.
Yes, I have prepared them already. Okay.
Perfect.
Can you see my screen?
Yes, everything looks perfect. So
okay.
The floor is yours.
Thank you. So first of all, my name is Baltes Octavian. I have studied computer science in University Lucian Blaga of Sibiu. Now I am studying at my master's degree in advanced computing systems. And this project was used by me for the bachelor degree. I was coordinated by Professor Adrian Florea. And my idea of project is how can we automate the assembly lines with the help of an M-bot and a robotic arm. Okay, and the objectives for this project are to replace, for example, the AGVs in an industry, in a company, with mobile robots, all controlled remote, and replace humans with smart robots. Okay, for this project, I also used this approach suggested by OmiLab because I think it fits very, very well. Okay, the first part in this model is the design thinking part, which is the most creative part, where we design and we create an idea of how the problem will be solved. So for this part, I used Scene2Model to create my scenes. Scene2Model is a tool created by OmiLab, which can, with a camera and this tool, you can, how can I say, you can project the images from the board, scanning the QR codes into your application. And it's very easy. With just one click, you have created your idea. You have transferred it from the board to your computer. For my project, I needed 4 scenes. The first scene is where the robot is loaded with the pieces, and the second one is when the robot transfers the pieces to the robotic arm, where the parts will be separated. The third scene is where the robotic arm separates the pieces, put them in the right container, let's say. And the fourth scene is where the mbot comes back to the loading station and gets filled up with pieces and goes back to the robotic arm and so on. It's a cyclic action. By creating the scenes in the Scene2 model, we have them there, but we don't have a specific order, and we don't have a good idea of how the actions will take place. So we can use a storyboard object where we can put the scenes one by one and have a better image of how the process is going to take place. This is for my example. Okay, the second part is the conceptual modeling part, where we go deeper and we explain our actions described in the previous part in the design thinking. So here we use a BPMN object where we create our steps. Let's say how everything is going to take place. For example, these are the 4 scenes translated into the conceptual modeling from the design thinking. So here we don't have the image, and we know for sure how the problem is going to be solved and how everything will go. If before in the design thinking part we just have an image, not a good idea of how everything is going to take place, now we can see very clear how everything is going to happen in our scenario. Okay, and the last part, the cyber physical systems, is even deeper. Here things actually happen. We see something physical, we can see things moving and solving the problem. Here are the actors that I used for my project. In the left image we have the mbot, in the right image we have the robotic arm, and in the middle the path the mbot has to follow to solve the problem. Okay, in the left side it's just an overview of how the flow chart looks like. The flow chart is made by submodels, and those submodels are described in the middle. These are the actions that I used to create my project. Here is an example of how one model should be used. The first one is drop off at position left. Starts the flowchart with a starting object where we set our URL for which device are we using. In our case, we are using the Dobot and setting the X, Y, and Z positions where the robotic arm should go. In the second object, the setmap header, we have an important information, and that is we tell the application that we have to do with a JSON object. The third object is move arm to position. Here we have the operation code which tells the robotic arm to move itself to the given position with the X, Y, and Z setted earlier. And the last object, the drop object operation, is just a request sent to the robotic arm to turn off the suction cup. It means that after he moved to the left container, in our case, we have to turn off the suction cup to release the piece into the container. Here is the video of how my application works. So the M-bot is filled with pieces and goes to the robotic arm where it needs to be separated. Stops onto the gap, and the Dobot will start loading the pieces into the container. For my example, I choose to pick up two pieces and store them in the left container, and then it will come back to the loading station, fills up with two more pieces, and then when he comes back to the Dobot, those pieces will be stored in the right side. Of course, this can be modified very easy, and you can do whatever method you want. I chose this just for an example. So he stored in the left side when he first arrived, and now it is storing in the right side. And this process can be done infinitely. But just for the example, I chose two times, one in left and one in right. Okay, the conclusions are, in my opinion, this kind of project can be used in industry very well and can be very useful. And from a software point of view, I used BApp as a tool for the cyber physical systems part and the flowchart as a working method. And for the design thinking and conceptual modeling, I used Synth model. In the future, I want to make the robotic arm smarter, attaching a camera so that the parts are separated based on QR codes. And apart from that, apart from automation problem, I want to make a project in which the arm is used as the 3D printer. As for the M-bot, I want to attach at least two proximity sensors so that it can move alone on an obstacle course. Thank you. This was my presentation. If you have any questions for us.
Thank you very much. I have a question. It looks really very smart. How much time did it take you to prepare such scenarios so that all those elements work so smoothly and so nicely?
It is hard to say. We got the devices in February, let's say, and in March, because of the pandemic, it was the lockdown and we couldn't access them. Only in, I don't know, May or something like that. And to prepare our projects for the bachelor degree, I think we could use them for a month and a half or something like that. And between before accessing the devices, before the lockdown was free, or I don't know how to say, we did some research. But until we used the devices, we didn't know very much how to use them and how they work. So let's say we had a month or a month and a half to prepare for our projects.
Thank you very much. In your part, you mentioned what are the possible outlooks and maybe questions also to your colleagues. Do you have any other ideas what you could do as the next steps?
With the M-bot or the robotic arm?
With both elements.
With?
So do you have a vision of what would be the next steps, apart of course from those that you already mentioned in the presentation?
Yes, we were thinking about how would react to mobile robots on a course. For example, if they meet one in front of each other, how will the priority be given between those two? Who will pass and who will wait until the other one is passing, based on a priority or something?
This is a very interesting question. So it will be indeed interesting to figure out how would it work if you have more elements. I have additional question from the audience. How would you compare flowchart with PetriNet as methods for modeling the presented cases?
I focused more on flowcharts because I found them more, I don't know how to say, I understand them better than PetriNets. And for me, I don't know, I like using flowchart rather than PetriNets. I don't know, maybe Maria can say because she also used PetriNets, not only flowchart.
Yes. I implemented the scenario using flowcharts and using also PetriNet. From my point of view, I implemented them in the same way. I mean, I used in PetriNet the same functions, let's say, the same flowcharts. I just called them in PetriNet. So I think we can implement them in the same manner. The only challenge for me remains that I couldn't make the PetriNet model simulated automatically. I mean, I can't make the PetriNet model to be started and the mobile robot to take itself the decisions on which way the model will be continuous. This is a challenge. It's still a challenge for me.
Thank you very much. I don't see any more questions. So I would like to thank you very much for participating today. Thank you very much to presenters for a very interesting presentation, and wish you all the best. Wish you a great Christmas and all the best in the new year. And I hope to see you on our next webinar in January. Bye-bye. Have care.
Thank you so much.
Bye-bye.
Thank you
Have a
so
nice
much
day.
for your invitation. Have a nice holiday and stay healthy, everyone.
Thank you. Bye.
Bye-bye.
Bye.